In previous lessons, we described the activities and decisions associated with discovering and understanding the major elements of the user's requirements. In other words, the analysis activities. In this lesson, we will focus on the solution system. During analysis, the focus is understanding what the system should do, whereas during design, the focus is on the solution, especially how the system will be built and how the structural components of the new system will be. New developers often ask, when are these tasks carried out in real project? Unfortunately, there is no single answer. Many projects begin with some of the design decisions having already been made, particularly with regard to the deployment environment, when companies already have a strong technology infrastructure in place. For other projects, the new system may be the result of a new trust of the organization, and thus the decisions are wide open. However, it is normal for the project team to start thinking about these issues very early in development and to begin making preliminary decisions as requirements are being defined. The topics that we will discuss in this lesson are solution-oriented design topics. However, you shouldn't try to come up with a new complete solution until you understand the project. The term design has different meanings depending on the context in which it is used. For example, when designing a poster or banner, the designer is primarily concerned with the message, text, and images, including their placement and stylistic elements such as fonts and colors. The designer may also consider materials such as paper for a small poster or tough and resilient plastics for a large banner stretched across a street. A good poster or banner design captures the viewer's attention, clearly communicates the intended message in a way that leaves a lasting impression, and produces the final product durable enough to last as long as needed. The entire design can typically be completed by one person in a matter of hours or days. In contrast, design of a commercial aircraft is much more complex and concerned with practical and functional aspects more than with stylistic ones. Design typically starts with macro-level considerations such as the aircraft's shape, size, and the number and placement of engines. From those decisions, designers move on to lower-level details and subsystems, such as internal engine mechanics, control surfaces, and fuel storage delivery system, hydraulic flight controls, and myriad electrical subsystems. Designers also focus on minute details such as the placement of rivets and welds, the size of the shape of seats, and the placement of cockpit displays and control devices. Because aircraft are so complex, multiple designers work over a period of months or years and coordinate their efforts with extensive drawings, mathematical models, and other design documents. The drawings and models also provide a way for designers to communicate with project managers, part suppliers, designers of production machinery, and the crews that will eventually build the planes. In Chapter 1 or in Lesson 1, we define the term systems design as those system development activities that enable a person to describe in detail how the resulting information system will actually be implemented. That definition was preceded by a definition of system analysis, which is those systems development activities that enable a person to understand and specify what the new system should accomplish. The sequence of definitions implies that analysis precedes design. That is, to design anything, you must first understand and specify what the final product will accomplish. In case of a banner or poster, analysis describes the message to be conveyed and physical aspects such as physical size and where it will be displayed. In the case of the commercial aircraft, analysis determines requirements such as carrying capacity, fuel consumption, range, maximum speed, reliability, maintenance costs, longevity, and maximum construction cost. Those complex and interdependent requirements drive a complex and interdependent set of design tasks. The latter part of the systems design definition describe how the resulting information system will actually be implemented. That is, designers provide the plans that orders follow to build the final product or system. In case of a banner or poster, the designer provides a full-size or reduced scale drawing and a set of construction specifications such as size, material, thickness, and placement of mounting grommets. The entire design is described in a few pages. In contrast, the commercial aircraft design is described in thousands of documents and drawings that include detailed specifications for every part. In both cases, design results are recorded in documents and models that provide sufficient information to build the final product. This figure here summarizes the aspects of design that you can glean from the poster, banner, and aircraft examples and apply to information systems design. First is that we analyze or analysis provides the starting point for design. And then design provides the starting point of implementation. And then analysis and design document the results to coordinate the work of multiple people and communicate with downstream activities. During the analysis activities described in the previous lessons, we created documents and models for object-oriented analysis. We create models such as class diagrams, use case diagrams, activity diagrams, system sequence diagrams, and state machine diagrams. Regardless of the approach, design activities begin with documents and models created during earlier analysis activities. In other words, analysis outputs are design inputs. In iterative projects, analysis and design activities are often done concurrently. However, the first focus on any iteration has to be identifying and specifying the requirements for some part of the system, and determining the solution comes later. During analysis, analysts build models to represent the real world and to understand business processes and the information used in those processes. Basically, analysis involves decomposition, or breaking down a complex problem with complicated information requirements into smaller, more understandable pieces. Analysts then organize, structure, and document the problem domain knowledge by building requirements models. Analysis and modeling require substantial user involvement to explain the requirements and to verify the models are accurate. Design is also a model building activities. Designers convert the information gathered during analysis, the requirements models, into models that represent the solution system. Design is much more oriented toward technical issues and therefore requires less user involvement and more involvement by other systems professionals. The output of design activities is a set of diagrams and documents that models various aspects of the solution system. The formality of a project also affects design. Formal projects usually require well-developed design documents typically reviewed in formal meetings. Developers on informal projects often create their design with notepads and pencils and then throw away the design once the program is coded. This kind of informal design, used in many agile projects, is merely a means to an end, which is the actual program code. However, even in agile development, the design activities described in this lesson are still completed. A developer who jumps into writing software without carefully thinking it through, often referred to as a cowboy coding, ends up with errors, patches, and systems that are unreliable and difficult to update.